Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be looking at scientific notation. And what is a scientific notation, alright? So scientific notation is used for either very big numbers or very small numbers. And usually scientists use this because whenever you have a very big number you don't want to have to write out all the digits. And same thing with very small numbers. You don't have to write out like 0.000000 and get to the digit you want. So scientists use scientific notation in that case. Also, sometimes you will have trouble indicating the right number of significant digits when you take a measurement. So, for example, let's say you had the number, let me write it down for you. Let's say you had the number 5,000, okay? So we've looked at this before, and we know that if you wrote this down, you have the correct number of significant digits here is just 1, just the 5, because these are trailing zeros which are not to the right of the decimal point. However, let's say you wanted to make these 3 digits significant. Okay, so using our traditional significant digit rules, there's no way of doing that. So scientific notation helps indicate the right number of significant digits when you're having trouble indicating the right number of significant digits. Okay, so the rules for writing a number in scientific notation is that you you take the number and you write it as a number between 1 and 10, but not 10 itself, and then you take that number, multiply it by a power of 10 to keep the value. So let's go ahead and look at a few examples. So here we have 18,960,000,000. We have 18,960,000,000. Okay, so what we're going to do is we're going to take this number and express the number as a value between 1 and 10. So the way we do that is we'd say this number is 1.896. Okay, so it's a value between 1 and 10, this number here. And then in order to keep all these zeros, we're going to take this number and multiply it by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the power of 10. Okay? And then that way the decimal point will move those 10 digits in order to get the correct value. So again, the way I got this 10 here, I counted the number of digits past the place value. So if you look here, if I put the 1.8, so I'd start counting at the 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Let's do this again here. So we have 310 million. So in order to get this between a number of 1 and 10, we'd say 3.1. And then to keep our place value, multiply by 10, and then raise that to the power of 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now here we have a very small number, so we're going to do the same thing. So 5.4, make that 5.4, and multiply it by 10, and now we're going to have to count the digits in front of, from the 5 to the left. Okay, so we start at 5 and we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'd say negative 10. 5.4 times 10 to the negative 10th power. Let's do it again here. 8. We have 0.00008792, so we would express this 8792 as a number between 1 and 10, so that would be 8.792, and then multiply it by 10, and in order to find what power we're raising it to, we'd start at the 8 and start counting 1, 2, 3, 4, 5, so negative 5. Alright, pretty simple. Now let's look at the second part. So we know how to write very big or small numbers using scientific notation. Now let's see examples where you have trouble indicating the right number of significant digits, and you're going to have to use scientific notation in those cases. So here, write the number 400 with 3 significant digits. So in order to do that, we're going to write this number using scientific notation, but we'd say 4.00 times 10 to the second. Okay? So if you look here, the number of, if you placed our decimal point here, that's why we have 2 here, because the numbers past 4 is 1, 2, so our power is 2, okay? So we've accounted for that. But instead of writing 4 times 10 to the second, I've written 4.00 times 10 to the second, because this number right here, 4.00, has 3 significant digits. So we've expressed 400, but in this case we have 3 significant digits, okay? Because these are trailing zeros to the right of the decimal point, making these zeros significant. Alright, here let's do the same thing. Write the number 450,000 with 4 significant digits. So let's first write this number as a number between 1 and 10, so we'd say 4.5, and then multiply that by a power of 10 to keep the place value. So that would be, the power would be, start at 5, so 1, 2, 3, 4, 5. But then we want to write 4 significant digits. We already have 2, so we can write 0, 0 to get 4 significant digits. These are trailing zeros to the right of the decimal point. Alright, and then we've expressed this number here, but with 4 significant digits. Last example here, write the number 0.03 with 5 significant digits. So let's go ahead and express this number using significant digits. Express this number using scientific notation first. So we'd say 3 times 10, and then since our decimal point is right here, we'll count this way. So this will be 3, and then 1, 2. So 3 times 10 to the minus 2. If that confused you, the decimal point is right here, okay? So we'd count the numbers in front of the decimal point. So starting with a 3, 3, and 0. So that's why we get the minus 2. Okay? And then now we want to express it with 5 significant digits. We already have 1, so we'd write 4 more trailing zeros like this in order to get the 5 significant digits that we want. Alright? So that's how we use scientific notation. It's as simple as that.